Hi there, this is Calculus Integrals, and it's the second portion of Definitive Integrals. And in this one, basically, I'm going to just discuss properties of integrals and also the connection between derivatives and integrals. And then we'll just run through essentially some explanations. So, first of all, one thing, previous topic was antiderivatives. Well, if you went through that video, you'll realize that essentially antiderivatives are the same thing, practically, of integrals. So that's the first point that you need to realize. Pretty simple, pretty straightforward. If you're doing an antiderivative, you're doing an integral. Okay, so let's just start off. Basically what we do is we can just take properties from that we know of antiderivatives and convert them into essentially properties of integrals. So I'm just going to say of integrals. And essentially, let's just start off. We know that well, let's start with something a little bit more subtle. Some people have asked me, hey, what's the effect, what's the difference if you just switch the order of these A and B's? Well, as long as they don't equal the same thing, that'll equal negative BA. So all switching that does, X, all that does is toss a negative in front. So if you find it easier to switch them for any given problem, then you can solve it. Now, when A equals B, I know I had mentioned that before, that is a special case. And actually I guess the last property does hold, but it just holds for anything, right? If A equals B, well, essentially that's the same thing as saying A to A, what's f of x dx, and I'm just here to tell you that that equals 0. And the reason that's true is because, well, when you have A to A, that's like saying, you know, like if you look at it graphically, you have some graph, and A to A is essentially just this point. That point. Thus our delta x equals 0. Thus when we do the series that was explained in the other video, essentially that delta x is 0, everything just multiplies out to equal 0. So that's how that one works. Well, you know, you can have similar problems as we did in derivatives, where it's just the constant times f of x. And I'm here to tell you that essentially you can do the same thing. You just pull it out. You just say, hey, you know, that's the same thing as AB f of x. What if you had a derivative of, when it's AB, what if you had the derivative of a constant, so c dx? Well, that's the same thing as c times, and what does dx turn into? B minus a. B minus a. So, I mean, and you could even graphically show that just by right here, c. What does y equals c look like? Y equals c looks like a flat line between B and A. B and A. Well, see that? This distance right here is B minus A. And this height is C. So that's why. It's essentially just the area underneath this curve. just like we explained in the other video. Alright, so, continuing on, I would probably like to talk about the last two, which are pretty similar to what you saw in derivatives. And I'm just going to put a and b here. I mean, you can switch these things around all you want, but the concept is that f of x plus g of x, the whole derivative of that, is the same thing as derivative of a b f of x plus the derivative of a to b g of x. Same thing. And I'm not going to explain it, but well, I'll explain it. You guys got me. A and B. And as I'm sure you would have just assumed, but we're here to concrete ideas, not assume, that the concept applies for also subtraction, not just addition. So, alright, so let's run through some explanations of these. I'm just going to give you essentially a layout of how this would work. Let's do between 1 and 0, you will see 15 dx. Okay? The integral of that. Well, we just look at our function right above, this one right here. That's going to be c, which is 15, times b minus a, right? Which is going to be 0 minus 1. Or in this case, actually, it would be 1 minus 0, top minus bottom. So 1 minus 0. Let me make sure I didn't make an error there. Yeah, okay. Up here, guys, this should be positive. You just need to realize that b minus a, that just means this minus this. So it's the difference essentially between here. So the difference between 1 and 0 is 1. So you just need to pay attention, make sure you're not making any errors. So the answer is 15. But okay, let's go on to something a little bit more complicated. Let's see. How about, let's just figure out why when a equals b we get the answer 0. Well, f from 1 and 1, you're going to get f of x, whatever, dx. It doesn't really matter what the function is, I just want to show you why. If you found out, if you remember the function of how to determine delta x, it is a minus b, which is a minus b, which is a, over n. Well, that just equals 0 over n, which equals 0. So your delta x is equal to 0. And that's how they determined it. So, let's lay out a couple different ones. A couple more. We just solved this one up here. So I'm going to actually split this apart and redo it and just show you that you can get the same answer by doing addition technique. So basically you'll have 1 and 0, right? And 15 dx, okay? Now realize that this is the same thing as 1, 0, 10 dx plus the integral of 1, 0, 5 dx. That's what I propose, that is the same thing, that they equal each other. Well, we know the answer to this one. That's right above. That's right above. It's 15. What if we solve these two individually? Let's do it real quick. You have the integral of this one, which is going to be 10 times 1 minus 0 plus 5 times 1 minus 0. Well, what do you know? 10 plus 5 equals 15. Now I know that probably seemed really simple, but I just wanted to show you that that applies, and it does come out true regardless of what you put in there. Just use these concepts and you can shift a lot of different functions in different ways. So let's run through some examples. I think that would make everyone a little bit happier, and I'll see you guys in the next video.